In this video, I'm going to talk a little bit about integrating powers of trig. So that means when we have these powers of trig functions in our integrand, like sine to the m, cosine to the n, secant to the m, tan to the n. And so there's some kind of simple rules that we can follow in computing these integrals. So if the power on sine is odd, we let u equal cosine of x. If the power on cosine is odd, we let u equal sine x. If they're both odd, either of the substitutions will work, and if they're both even, we have to apply some trig identities. If we're integrating powers of secant and tangent, if the power on secant is even, we let u equal tangent x. If the power on tangent is odd, we let u equal secant x. And if m is even or n is odd, either of the substitutions will work. And if m is odd and n is even, there isn't a standard method. So let's kind of review some of the trig identities that we're going to need to solve some of these problems. So firstly, we know that sine squared theta plus cosine squared theta equals 1. We also know that tan squared theta plus 1 equals secant theta squared. And then two more identities. We have that sine squared theta is equal to 1 minus cosine 2 theta over 2, over 2, not an arrow, over 2, and cosine squared theta equals 1 plus cosine 2 theta over 2. Okay, so let's start solving some problems. So we have the integral of sine squared cosine x dx. So I will notice that the power on my sine is even, so I will let u equal sine x. Then du by dx will equal cosine x. So my du equals cosine x dx. Cool. So this cosine x dx right here matches this, so in my substitution those guys will cancel out. So why isn't it erasing? Okay. So I have under my substitution the integral of u squared, because sine is my u, du, because cosine x dx is my du. Now this is just 1 over 3 u cubed plus c, and then doing my substitution, 1/3 sine cubed of x plus c. Okay, and that would be my final answer for that one. Now let's look at one where our powers are not 1. So I have sine cubed of x cosine squared of x dx. So I notice that my power on sine is odd, so I'll let u be cosine x, but there's a simplification we can do first. So I will notice that I have that this is the integral of sine squared x cosine squared x sine x dx. Now the reason I do this, I just split this sine cubed up into two parts here. But the reason I do this is because I can take advantage of the identity that sine squared x is 1 minus cosine squared x, and I have cosine squared x and then sine x dx. Now doing my u substitution, I will let u equal cosine of x, then du will equal negative sine x dx. So under my substitution, this integral will become the integral of 1 minus u squared times u squared, and then this sine x dx is negative du, so this is times negative 1 du. Now I'll go ahead and bring this negative outside and distribute this u squared. So this is negative integral of u squared minus u to the 4th du. That's really easy to solve. We just use the power rule there. So it's negative 1/3 u cubed minus 1/5 u to the 5th plus c. And then doing my substitution and distributing that negative, this is 1/3 cosine cubed x plus 1/5 minus 1/3 plus 1/5 cosine to the 5th of x plus c, and that would be my final answer. Okay. moving on, we have the integral of sine to the fourth of 2x cosine squared of 2x. Now both of my powers are even, so I need to apply some trig identities. There's not a u substitution I'm going to do here, and we're going to use these identities here, these power reducing formulas. And I'll show you how here. So we're going to recall that sine squared theta equals 1 minus cosine 2 theta over 2, and cosine squared theta equals 1 plus cosine 2 theta over 2. So we can rewrite this sine to the fourth as sine squared 2x squared, right? And then we notice that our theta here, the argument of sine and cosine, is 2x. So 2 theta will equal 4x here. So rewriting this, we have the integral of 1 minus cosine of 4x over 2 squared times 1 plus cosine 4x over 2 dx. Okay, so I can go ahead and pull these denominators out here. So this is going to be the integral of 1/4 that comes from this 2 being squared here, of 1 minus cosine 4x squared times 1 plus cosine 4x. And then I'm going to go ahead and pull out that 1/2 as well. So I'll put that up here. Okay, dx. And then I'm going to notice something here. So rewriting this is going to be 1/8, I'm pulling this 1/2 forward, times 1 minus cosine of 4x times 1 minus cosine of 4x times 1 plus cosine of 4x. I just split this square up into 2 separate factors. Here I can use the formula for difference of squares. It's going to make this a little bit easier to compute. So this is going to be, I'm going to move this 1/8 outside. 1 minus cosine of 4x times 1 squared is 1 minus cosine squared of 4x dx. Now I can go ahead and distribute, actually I can go ahead and multiply these using the binomial expansion, sorry. And this will be 1/8. So I'm going to go ahead and FOIL this. This is going to be my first terms, 1, and then my outer terms. So that's going to be 1 times negative cosine x squared, so negative cosine squared 4x. And then my inner terms, it's going to be negative cosine of 4x. And then my last terms are going to be these 2 cosines here, so I'll have positive cosine cubed 4x dx. Okay, so now what I'm going to do is I'm going to go ahead and split these up into separate integrals. So I'll have 1/8 times the integral of dx minus the integral of cosine squared of 4x dx minus the integral of cosine of 4x dx plus the integral of cosine cubed of 4x dx. So I just split all these terms up and multiply that 1/8 on the outside. So I know that the integral of dx is just x. I can find that pretty easily. For this next one, I need to again use the formula that I was using before. So I'll get, this is going to be 1 minus cosine of 8x this time, because 4x is my argument, over 2 dx. My 1/8 is outside, sorry. And then this is going to be the integral of cosine of 4x is going to be 1/4 sine 4x. So this will be minus 1/4 sine of 4x. And you can see that through a simple u substitution. And this is going to be, this last one, we're going to have to do a little bit more work. So I'll notice that this cosine cubed can be split up into the integral of cosine squared 4x times cosine 4x dx, and that's all being multiplied by that 1/8. Okay, so now I have 1/8 times x is already done, and then this is going to be minus the integral of 1/2 dx plus the integral of 1/2 cosine 8x dx, and then we already finished that 1/4 sine 4x, and then here we're going to do a u substitution, and we're going to let u, well, first we notice that this is 1 minus sine squared 4x times cosine of 4x. So this becomes now, let's see here, the integral distributing this cosine of cosine of 4x dx minus the integral of sine squared of 4x cosine of 4x dx. Okay, so that was just distributing this cosine here and splitting these into two integrals. Okay, and all of that is being multiplied by 1/8. I know this problem is really long, but we're about to be done. So moving on here, we have 1/8 times x, x, the integral of 1/2 is going to be 1/2 x. The integral of 1/2 cosine 8x is going to be 1/16 sine 8x, and you can see that through a simple u substitution, minus 1/4 sine of 4x plus, this is going to be 1/4 sine of 4x. This integral here, you can see that through a simple u substitution, and here we're going to let u equal sine of 4x. Then this will become the integral of 1/4 u squared du. Okay, almost done. So now I have 1/8, and I'll start combining like terms here. This is going to be 1/2 x plus 1/16 sine of 8x. These two factors here will cancel because I have, or I should say terms. I have a negative 1/4 sine 4x and a positive 1/4 sine 4x, so these guys will cancel. And then this is going to be minus 1/4 times 1/3 u cubed plus c. Okay, and then now we have 1/8 times 1/2 x plus 1/16 sine 8x, and then we got minus 1/12. My u was sine 4x, so this is sine cubed of 4x plus c. So wrapping this up, my final answer is 1/16x plus 1/16 times 8. 128 sine of 8x minus 8 times 12 is 96. So I have 1/96 sine cubed of 4x plus c. And that is my final answer. Took a while to get there, but our process was just keep applying these powers of trig here, or sorry, these trigonometric identities here, and kind of just doing the computation there. Okay, moving on, we're going to compute the integral of tangent cubed x secant to the 4th x. So I'm going to rewrite my integrand. Here I have, let's see. So I'll rewrite this as tangent cubed of x secant squared of x secant squared of x dx. So I just split the secant to the fourth up. Now, I notice that this secant squared x is the same as 1 plus tangent squared x. So we can rewrite this as tangent cubed x times 1 plus tangent squared x times secant squared x dx. And you might see where this is going. If I let u equal tangent x, then du equals secant x squared dx. Okay, now doing my substitution, this secant squared dx will go away, and I get, under my substitution, the integral of u cubed times 1 plus u squared du. This is just the integral of u cubed plus u to the 5th du, and that is 1/4 u to the 4th plus 1/6 u to the 6th plus c. Undoing my substitution, I get that this is 1/4 tangent to the 4th of x plus 1/6 tangent to the 6th of x plus c. Okay, we are done with that problem. Now I know this middle problem is kind of long, but it kind of shows the process of what happens when sine and cosine both happen to be even. And that kind of wraps up what I wanted to say about integrating powers of trig. And if you found this helpful, please consider liking and subscribing. Thanks.